SolidWorks Simulation, Lecture 7, Part 5. A partial model simulation for a natural frequency calculation. Open a part file. Enter sketch mode. Draw two circles. And for inner circle, the diameter is 10 millimeters. For the outer circle, it is 120 millimeters. And I'll draw two lines to connect the circles. And trim the circles so that the model become a quarter of a circle. And I'll extrude it to 1 millimeter. So this is a quarter model of a compact disc. So I'll save the model on desktop. And I'll load the software. So this is the first preparing step. The second preparing step is to load the toolbar, which is already here. And I'll open a frequency study. Now, I have finished with the first step in CAE analysis. And I'll go with the second step. And I'll choose plastics, PC high viscosity, polycarbonate for the CD material. And then for meshing, I'll use default mesh size, hide the mesh. And for boundary conditions, I'll zoom it in and I'll fix the inner circle, inner surface. Then I'll place another constraint using advanced symmetry boundary condition. I'll choose this surface and this surface so that it will become a full circle. So I'll place symmetry boundary condition on these two surfaces to make the quarter model a full circle. So I have finished with the boundary conditions, and I'm not going to place any load on it because I have talked about loading effect on the previous examples. So before I start running the study, I need to change the number of frequencies that I will let it calculate. And I'll enter 15 and run. So for quarter model condition, the result is that and I'll copy the result here. Then I'll change the geometry. I'll delete the result first so you can clearly see the geometry. I'll edit the sketch and eliminate all the sketches. And then I'll eliminate the boundary condition. And now I'll draw two full circles. The inner circle will be 10. The outer circle will have a diameter of 120. And extrude it. So I'll extrude it to a millimeter, just like before. So now we have a compact disc, a full circle model. So now I will go with maybe I'll create a new study, frequency study, and do it again. So this is a complete geometry, complete model. So the second step, I'll also choose the same material, plastic, PC polycarbonate high viscosity. And for the boundary condition, for the meshing, I'll accept the default mesh, hide the mesh. And for the boundary condition, I'll fix the inner circle. And I'm not going to place any external load on it or rotating speed because it is covered on earlier lectures. And now I'm going to determine how many frequencies to calculate. And I'll go ahead and proceed with the calculation. So this is a full model calculation. So the result is here. I'll copy the result and paste it here. So we can compare the difference. For example, 81 here. So this is absent. This frequency is absent in the quarter model. So 101, this is absent, right? 101 here, right? 402 here. 403 is very close. And 481, so this is very close. And then there are 3 frequencies. Actually, these frequencies are also absent in the quarter model, right? So we're going to look at, for example, the first model. The first model is absent in the quarter model, right? So we can see how or why the model is absent in the quarter model. So I'll play the animation here. So you can see here that the vibration mode is two-fold symmetry or 180 degrees symmetric. So it will not appear in a quarter model because it is a two-fold symmetric vibration mode. So a two-fold symmetric vibration mode of 180 degrees will not appear in a quarter model. So it is apparent, right? So let's look at here. This is the 6 and the 7 mode, right? So let's look at the 6 and 7. This is the 6th and this is the 7th. Look at these vibration modes. We can play it on animation. So these modes are 6-fold symmetric, and it is 120 degrees symmetric, right? Or 60 degrees symmetric. So apparently it will not appear in a quarter model. In a quarter model, it is 90 degrees symmetric. And in a full circle, in this mode, it is 6-fold symmetric. So a 6-fold symmetry will be symmetric in 60 degrees or 120 degrees. And it will not appear in a quarter model. It is apparent. So now, let's look at another one. Here. And this is the 10, 11, right? 11, 12, and 13. So let us play 11. This is also a two-fold symmetry, right? Two-fold symmetry. And this is what? One-fold symmetry. Right. It is 360 degrees symmetry. So you can see that it is not compatible with the quarter model, and also 14 and 15 frequency is not presented in a quarter model frequency. The reason is that it is 12-fold symmetric, and the symmetric angle is about 30 degrees or 60 degrees. So it will not be a be compatible with the quarter model. So you can see from here that although you can use a portion of a model in a static analysis, you cannot use portion of a model in the vibration frequency analysis, because you will miss some of the frequencies that are presented in full circle, and they are not going to present here in a quarter model. So you'll be very careful about using portion of a model in natural vibration analysis.